Now let's go to the Linux tools, WC and cut. So we will learn about how to use WC, word count, and we'll try some examples. We'll learn about cut and try some examples. And this command here, WC, it's a command that calculates a file's word, line, character, or byte count, and returns the values in that order from left to right. So the syntax is WC, and some options, and these are some of the common ones, and then the file you're doing this on, or many files it could be as well. So -L will just list number of lines, M is number of characters, and W is number of words. And for playing with these examples here, we are going to use the same directory as before. So we are still in the piping WC cut directory, and we have these files here as before. So please type along. So if I just say WC and no options on a file, and let's randomly pick the one, there should be one called myfile1.txt, it's here. So I will do WC myfile1.txt. And as you can see here, it has 4 lines, 15 words, and 80 characters. Let's try and look at the file. The right one. And you can see here there is indeed 4 lines, and it seems reasonable. There are 15 words and 80 characters. You can count them if you want to. You could also say, let's run word count on all files with suffix.txt. Let's try do that. And then it outputs all of them here. And it also makes a total. This will be approximately the same as I show here, though there will be the difference that list.txt, which we generated under the chapter about pipes, will be there as well. And yeah, it has summed all the lines, words, and characters. So what if we just want to see the lines? You can do that if you add the option -L. So let's do that. WC -L. And we could do it on myfile1 or on myfile2. And it shows how many lines. What if we want to use what we just learned in the previous section and combine it with pipe so we can sort it? Well, let us look at word count, WC on all text files, and then we sort it, as you can see here. And it sorts it first by the first column. And we get the same output, except for list.txt being there as well. So what happens if you accidentally gave the command WC and did not give it input? Well, it will assume it should wait for input, and that means that it will just sit there. So if I said WC, nothing happens. It's sitting there, it's waiting for some input. And you can escape it with Control-C. And you do that by holding down Control and pushing C. So this hints that it can capture output, and it can. what assumes you have a large number of files that you want to run it on. Uh, and then you could not just get the output thrown to screen. It would be better to get the output to a file. And you can do that, of course, with a redirection. This is a simple redirection. So this is the output. Let's try and look at that output. It's long, but not so long. But if you had a small screen or if it was a bigger output, it might be annoying. So let's try and throw it to a file. And let's just call it file length.txt. And now we have a file that's called file length.txt, and it contains exactly what we just output here. Then let's see what let's see if you have if there is a lot of files, it might be better to do this. Otherwise, you could have set it to either less or more with with the operator type, and we could do that instead. So instead of that, we will just put in the operator here, pipe, and then we'll say more. And since it was just a moment, I'll do it here instead. So WC minus L on all the text files, and then more. And then you can see you could do it this way instead. So it kind of depends on what it is you're doing, if you want to use an intermediate file or if you want to use something like more or something different. So let us make an exercise here to try how to work with the WC. And you can play on these suggested files here if you want to, or you can try other ones. But let's again take some minutes for this. Let's take 5 minutes here as well. It's good to actually get these exercises done, I think. So let's take 5 minutes. If you get the exercises done quickly, you can try and combine them with the various pipes to the output and see what you get, just to get some experience in playing with it. Okay, so let's continue with cut instead. And cut is a command that you use to extract sections from each line of input. And the syntax is cut, and then there are some optional options. So it could be -b list, -c list, -f list, where it's bytes, characters, and fields. And it could also be -n and -d delim, and that is a specific delimiter that you use that you have separated your file in. It could be space, or it could be tab, or it could be commas. In default, it's tab, and then -s and file. So if you are you need to give a range because you are saying it's a section, and it should be one of n and n minus m and n dash, which means from n the number to the end of the line, or minus m, which is from the beginning of the line to the point m, where n and m are counted from 1. There's no zeroth value here. So if you do -n combined with -b, it suppresses splits of multi-byte characters. -s bypasses lines which has no field delimiters if you specify -f fields, unless otherwise indicated. So let's try and do some examples to better see what this means. And we are again going to use the directory piping wc cut under exercises to run some examples on. So let's try and use the -b flag. -b was bytes, and -b n for the first n bytes of a line. Let's try look at new file.txt, and I'm going to show you what is in new file.txt. So you see it looks like this here. And so let's use cut -b1. So we are saying we want the first 1 bytes of a line. And so you get the first one here, which is TSSM, as expected. And you could also take the second one instead. And then, unsurprisingly, we get the second one here instead. HOTU. What if we specify a range? We can do that. Then in this case here, the range is from 2 to 5. So it's HIS, and then there's a space. That is 2, 3, 4, 5. And in the next one, it's these. So you can see it truly takes it as those fields. It doesn't matter if there is something written there or if it's a space. It's still counted because it's still a byte. And yeah, this is how it looked in this file. What then if we use -c? Now, as you remember, -c was characters. So let's try and ask for a range of characters. And this should give us the exact same thing here. In this case, there should be no difference. Let's try. And there is indeed no difference in this case here. They are saying that they are adding multi-byte support and that may enable different behavior in the future. But right now, as you can see, those do the same. So what if we try and use a delimiter as we talked about? And a delimiter could be anything. It is tab as default, but in this file we have here, and I'm going to show you this file 8.txt. Tab is not probably a good choice because most of these breaks between the words are spaces. So because of that, it's probably better to pick space as a delimiter. So we are going to do that. So let's try and do cut -f, and let's take 2 to 4, and then we are using the delimiter that will be space, and then on this file 8.txt. And F, you can remember, was fields. And this is, for instance, a word. So you're taking from 2 to 4 in the first one. I will again do cat on this file 8 so you can see how it looked. So on the first line, 2 to 4, there's actually only 2 because there's 1 here all the way to our delimiter, which is now a space, and then the next one. So this is 2, number 2 field. And in the next line, you have several spaces. So you go in 1, 2. So we start here this is, and that is also what you have. So when you have a text file like this, it doesn't make so much sense. But imagine that you instead had a table with some numbers, some data output. And in such a case, then it might make a lot more sense that you are now saying, I will grab from column 2 to 4, for instance, or something like this. And in this case, delimiter was space. You could use a different delimiter. So let's imagine you're using colon, because in this file here, there are some colons you can delimit it with. And you could also just say, I want to see it from 3 and to the end. So this is useful if you have a huge table with data and you just want to see maybe column 3 and 4 because that's the one you are interested in working on. So here this is useful. So -C is used for fixed length line. Most Linux or Unix files don't have fixed length lines, so you should rather cut by fields than columns, and this is what we are doing here. List of the fields number specified must be separated by comma, and you can also range are not described with -F option. Cut uses tab as a default field delimiter, but as you saw here, you can use any other delimiter that you are giving with the -D option. And that's useful because it might be that you, as I said, have data in a table and it might be divided by tabs, it might be by space or by comma or colon or something else entirely. And then you can use your own specified delimiter that you're using instead. And there is such a file to play with, namely data.dat. So let's look at that. And it's a small file, but it has 4 columns and 4 rows with some numbers. And there you can see that you could cut for 2 and 3 and delimit it by space. And if you did that, then you get column 2 and 3 and that as output. And there is a situation where it's actually useful. I did something wrong. Cut minus F. Isn't it called data? I forgot to put the minus D. And then you can see here that it takes those 2 columns. And this also, I have an exercise here that I would like you to do. And you should play with, for instance, this small file data.dat. But you could also create a file yourself where you use colon delimiters or some other delimiter and see what happens. And you can try and select for the first part or the last part, middle part, or maybe just the first byte, so the first character or something. So go ahead and try these exercises. And let's again take 5 minutes because then it will we'll just have a couple of minutes to do the summary and then a break. So until 10:02.